Okay, welcome back to ITP 115, Programming in Python. Today we're going to be talking about the second part of 2 on functions, and this is going to be the first video of 3, and in this video we're going to be talking about global variables or global constants. So before we talk about what a global constant is, let's first talk about what a constant in and of itself is. So when we say constant in programming, we're really referring to the value. We're saying that the value of this variable is constant, or in other words, the value of this variable is not or is not going to be changing over the life of our program. And there are real life examples where we want this. Suppose that we were going to say that the sales tax rate was not going to change over the life of the program. We can safely say that over the course of our lifetime, the speed of light is not going to change. And it's also important to note that in Python 3, this is a style or convention. It's actually not enforced by the language specification, which means that we're going to stylistically mark a variable that we want to have a constant value by making it all uppercase and using underscores instead of camel casing, right? Because we can't have spaces in variable names anyway. And so when you see all uppercase with underscores, think to yourself, okay, the value of that variable is not going to and should not change over the life of our program. A global variable is something that can be used anywhere in our entire program. It has what's called global scope. It is defined in what's called the global namespace. And the way that we mark namespaces in Python is through indentation. So when we define a variable inside of a block of code, its scope is that block of code. Whereas when we define a variable without any indentation, right, then it's at the global level. To the far left of the file is the global namespace. And once we put it in that global namespace, it can be used anywhere in the program, meaning where it is defined or inside of any other functions in that file. So inside or outside of any functions, anywhere in that file that is defined. And remember, we say global constants should not change their values, right? We are agreeing as programmers to not reassign them. Let's look at an example. So here we have a file, right, called weather.py, and we are going to make a global variable. Far left of the file, no indentation, and therefore it can be used anywhere in this outer rectangle. This is what we're going to call the global namespace or the file namespace, whereas air quality is indented because it's following a colon here, and it is in this function block, or it is said to be local to this function. And therefore air quality can only be read and accessed inside of this function where it is first defined. So we say air quality and rain are local variables. Average temperature is global variables. The namespace of average temperature is what I have selected here, this outer rectangle. The namespace of air quality is this inner pink rectangle, and the namespace or scope of rain is this second, right, function 2's namespace or scope. Rain can only be accessed from function 2, and air quality can only be accessed from function 1, whereas average temperature can be accessed from inside or outside of one or both functions, really anywhere. It's global. It has global scope, global namespace. Global namespace defined by no indentation. Global scope, right, meaning this, it can be used inside or outside of function 1 and or function 2, like we have here. Let's look at this in PyCharm. So here we have a file. We could do this, by the way, right? We could define our global variable here. We're going to say it's constant by making it all caps, and we could reassign it. PyCharm will let us do this, right? Here it is running right here. I can change it. All right, Python 3 will let us do that. This is one of these things where you can do it, but don't, right? We're going to use this style to signal to other programmers using this file that we're not going to be changing this value over the life of our program. Here we have air quality being a local variable to function 1, rain being a local variable to function 2. Okay, and so you're probably thinking this is great, right? I can make a variable out here and use it in all of my functions. So why not make all my variables global? Well, the reason is state. Basically, what are the values over the life of the program? What are the values of all the variables over the life of our program? Coupling and cohesion, and basically debugging it, or in other words, when I have an error in my program and I'm trying to figure out, wait, why does average temperature have that value? Well, it can be accessed from many different functions. So finding out exactly where things went wrong with a given variable or variables becomes very hard. So because of that, we want to minimize variable scope. You want to make all of your variables as local as possible so that it's easy to see and easy to locate and pinpoint where the state of your program changed. And the way that we do that in programming is through function parameters and function returns, or in other words, high cohesion, low coupling, basically making what should be together stay closely together and what shouldn't be together stay far apart, separation of concerns, to make changing something localized and to make finding where things went wrong really easy. And so how we pass parameters and how values change has to do with whether or not they are mutable, which is what we're going to talk about in the next video.